This is Sarah Cook, and this is the circuit building project. And for this project, I will be demonstrating the effect of adding resistors, capacitors, and inductor coils to a circuit. First, I'm just gonna connect the AC source to the speakers, so you can hear just a regular audio sound. Okay, sounds clear. Just clear. Nothing else. Now I'm going to be adding a 100 ohm resistor to this circuit and see how that affects the sound. Oh man, I got too many wires. Too many wires. Okay. The sound is notably quieter, obviously, because that's what resistance does. It blocks or impedes the signal or hinders it from being heard to some extent. And obviously the more resistance, the less you'll be able to hear the audio frequencies coming through the speakers. So next I'm going to be adding another 100 ohm resistor to this series, and the total resistance for two 100 ohm resistors is it's additive since it's in a series. So it's going to be 200 ohms. Did that wrong? No, I did it right. And here we go. Yeah, so it's definitely quieter, as previously stated. More resistance, the less volume or anything, the less you're gonna hear, just in general. Okay, let's get this apart. Ready for the next part. Alright. Now I'm going to put these resistors in a parallel circuit, and a parallel circuit should be noticeably louder because there's going to be less resistance, because when you calculate resistance in a parallel circuit, the resistance is going to be the reciprocal, and therefore it's going to be just a lower resistance. So lower resistance, less resistance, the more sound there's going to be. Yeah, that's the simplest way I can think of it, to be honest. I mean, that's about it. Alright, and I'm going to be connecting, make sure I got this right here. Be connecting one side of the resistor to one side of the wire and the other side of the resistor to the other side of the stereo wire. So there's going to be 2 lanes for the signal to flow rather than one continuous thing. There's going to be more routes. And let's see how this sounds. Should be louder. Yeah, it's noticeably louder. I would say it's even louder than when there were no resistors on it. Let me see that again. Yeah, so yeah, the parallel circuit had a louder volume. Now I'm going to be adding a 5,000 ohm variable resistor. Variable is just like a knob or something. You can vary the resistance. Like, so yeah, I'm going to be doing that. And here we go. Take all this off, this whole contraption. Up here. Try to stay organized in all this cord mess. Alright. So look at one side. Let me see. Make sure it's on there all the way. Alrighty. Connect one side to there. Connect the middle. The middle. About to do that wrong. And here we go, the last cord. So since this is a variable resistor, obviously, like I said before, it's going to be the resistance, therefore the volume is going to vary. So right now it's like almost inaudible. You can't hear it. So the more I turn this knob, the less resistance that goes through the wire. And the more I turn it to the left, obviously the more resistance is gonna there's gonna be more resistance in the wire. I don't think there is ever gonna be a point where you don't hear it, or don't hear it. You'll not be able to hear it at some point, but there always will be a sound coming through it. So it'll be like negative infinity or something. So yeah. Less resistance, the more sound, the more resistance, the less sound. Holy crap, how did that happen? Oh, these are touching. Alright. Now I'm going to be adding a 10 microfarad capacitor to the series. And I wasn't here for this in class, but my instincts tell me that it's just gonna be another form of resistance, whether it be for certain frequencies or just the whole sound in general. Just going to add resistance to the circuit. Anything you add is going to add some kind of hindrance or something. And let me see. Alright, now I'm going to plug this up and see how the 10 microfarad capacitor affects the sound. Alright. It's like the whole low end has just been cut. Yeah, it's probably acting as a high pass filter or yeah, it's pretty much a high pass filter. It sounds like yeah, nothing really to add to that. So I'll just move on to the next one. I'll add another 10 microfarad capacitor to the series, and from what I learned, resistance in a series is added or additive. So technically, from what I learned, I'm pretty sure that the resistance is going to be 20 microfarads. If you add the resistance of the speaker, it'd be just 28. And I don't think I said that for the other one, or previously, the resistors. If you add the two 100 resistors, it'll be 200, and then in the parallel circuit, it would be 100, 1 over 100. You just add those together. And then whatever that number is, the reciprocal of that is the resistance. And whether or not you add the 8 is, I don't know. I don't really know, to be honest. But if you would add the 8, you would get some kind of decimal. But for the series, you add them. For the parallel, it's 1 over the resistance. And then that number will give you the resistance. Now, what the heck was I doing? Oh, okay. Now, putting these 10 microfarad capacitors in a series, and see how that sounds. That just sounds like it took. It sounds like actually. It took the mid-range more out, more so the low end. But you can still hear the bass loud and clear. So it's probably like a mid to low range filter, not filter, what is it called? It's a band. Well, anyway, it allows that band, that frequency to come through more clearly. That's what it sounds like to me. I mean, the high end is still kept intact, and the mid-high and the mid-range frequencies are still there, but the low end is somewhat compromised. So now I'll be putting these capacitors in a series. Here we go. Series takes forever. Putting these in a series. What is in a series? Are you serious? Holy crap, what is that noise? Alright, got one side of the circuit. No, I don't. I lied. I messed up. Yeah, I messed up. Oh, no, I didn't mess up. Okay, now I'm gonna do. Oh shoot, the wire fell. Did it fall? Pretty sure the wire fell. Holy crap. Oh, here it is. Fell off the thing. Alright, got one side of this. Now I'm gonna do the other side. Other side. This is just so messy. Oh my goodness. Really gotta keep track of this stuff. This goes to this. And one more connection. We'll see how the 210 capacitor microfarads will sound. Oh shoot. Where do I need to connect this? Somewhere, I'm sure. I just put it. Did I do that right? Yeah, I did it right. That sounds rather good. Probably here. Is that what I expected? Obviously the parallel would be louder, but I'm not hearing the that filter sound. It's just louder. Because there's less resistance in a parallel circuit. I thought there would be more high pass, but there wasn't. Now I'm gonna be adding a coil. Add a coil and a 10 microfarad capacitor. So I'm gonna add the piece of coil, then I'm gonna add the capacitor right after. Add it in. Alright. This video is really long. Oh my gosh. Okay. Holy crap. It didn't do anything. Why is it not doing anything? Why? Oh. Oh wait, no. I have no idea why. Maybe I have the wrong coil. Je ne sais pas. I'm guessing. Oh crap. You know what? I might have used the wrong coil. Oh shoot, just real quick. Oh man. Alright. Take this off and place these real quick. Should work. I have no idea. Didn't create this project. I hear nothing. Added a coil to the series and it did nothing. Put that on the record. I have no idea what that means. Maybe because all the energy is being stored or moved into the, I don't know, it should pass through it. I would think it would pass through it, but I guess not. So maybe because the coil is somehow storing all the sound or storing all the energy and not moving it or something, or and all the electrons stop because the coil is inducting, and pretty sure that means the electrons just stop in the coil. It just holds all the electrons in the coil. So that would make sense why there's no sound, I guess. And next I'm going to add 10 microfarad. I'm going to hurry this up. I'm like taking forever. Sorry, Riley. Alright. Add the capacitor real quick. See what happens. Nothing. Nothing happened. I don't know if that was supposed to happen. Je ne definitely sais pas. I don't know. Well, if you add more resistance to something that's already not flowing in the first place, then I guess silence would be expected. Oh, it's been real.